Howdy, students. Hope all is going well. And if not, pertaining to this class, let me know. I'm, attempting to be as available as I can to answer questions, but feel free to send them to me. I will get back to you as quick as I can. Anyway, let's do a quick example I think will be helpful for your quiz. So this is number 8 on page 1002 in the book from chapter section 15.8. Okay, so Lagrangian multiplier problem. So remember, if we have some kind of like a mountain, so here's a mountain, and actually we could represent that mountain with a series of level curves. We'd call that like a topo map, right? So the top of the mountain is a point, and then out from it we would get all of these sorts of little level curves. And so here's a mountain. And then we could have a person, and that person's going to go on a walk around the top of the mountain on a certain curve. And we want to know, where does this person reach the highest point? So where that is where they intersect a particular level curve. So remember, there's actually a level curve at every point here. So at this level curve, let's draw one in that's real nice. So at this level curve, here they were walking up the hill, because they're going across level curves. And then notice at this point right here, they were kind of got as high as they got, and then they go back down. The closer to this point they get, the higher they are. So at this point, because this is a level curve, we know that the gradient is perpendicular to it, pointing uphill. And on the constraint at the top, because it's tangent to a level curve at max, it has another gradient, which may be longer or shorter, but it points in the same direction. So if we think of a equation for the level curves, or the z value, we can call that f of x and y, and its gradient has to equal a multiple of the gradient we would get on the level curve, on our constraint. So, hope that clarifies it a teeny bit. On to number 8. Page 1002. Okay. So this says we want to maximize f of xy equal to the product of x times y squared, subject to the constraint that we are on the circle, x squared plus y squared, radius 1. So remember, a circle has the equation x squared plus y squared equals radius squared. And in order to convert this to a usable g, we need to set it equal to 0. So the g we want is going to be x squared plus y squared minus 1. Okay, so here's our g, here's our f. Now we need to use the Lagrangian multiplier equation. So we need that the gradient of f equals, so partial with respect to x is y squared, partial with respect to y, 2xy. That has to equal lambda times the gradient of g, which equals lambda times, and this is going to be derivative of that with respect to x is just 2x, the rest of it's a constant, and the derivative with respect to y is 2y. Okie dokie. scoot that over just a little bit there. Okay, so now if we were to write this out, since this is a scalar multiple, we can just scalar multiply it into both of the components, and this yields the two equations. So the x component has to equal lambda times the x component. And we need to have the y component equal to lambda times the y component. And don't forget, we need to have this equation equals 0. X squared plus y squared minus 1 equals 0, our constraint. Okay, so solving those, it looks to me, doesn't matter sort of which order we do it, but that one looks the easiest because I can simply cancel a 2 from both sides and a y from both sides, and I get that this implies that x equals lambda. We can then plug that into the top equation, and we get y squared equals 2x squared. And then we can simply apply that into the last equation, and we get that x squared plus 2x squared minus 1 equals 0, gives us that 3x squared minus 1 equals 0, or that x squared equals 1/3, which implies that x equals plus and minus 1 over the square root of 3. If we plug this equation back in for that, we get that we can solve for y as, so this is going to be 2 over the square root of 3 squared. So that's 2 over 3, and then we have to take the square root to get y. So this is the square root of 2 over the square root of 3. Okay, so that gives us our point. We should note this equation is symmetric in all 4 coordinates, so its value here is going to be basically the same as its value. Let's see if x is positive and y is negative. So here, its value here and here are going to be the same. These are going to be negative, so they can't be maximums. These two are both the same value, so that just comes from having a plus or minus here. Excellent. I hope that was helpful. Just as a teeny thing, if I have to do the double integral over a region that's a rectangle, so let's say I have a less than or equal to x less than or equal to b, and c less than or equal to y less than or equal to d, f of x and y, d area, then this d area, I can write the dA as dx dy, or I can do it dy dx. As long as it's a rectangular area, order doesn't matter. So make it easy. Just as a hint, I recommend x first. Hope that helps. See you in recitation.